So alcohols in which hydroxyl group is attached to the secondary carbon atom is called secondary alcohols. So alcohols are classified into monohydric alcohols, dihydric alcohols, trihydric alcohols, and then polyhydric alcohols, wherein carbon-carbon double bond is there and the hydroxyl group is attached to the carbon, which is already having a carbon-carbon double bond. Hello dear students, I am Roja, your chemistry lecturer from Vidhyaashram PU College, the Temple of Excellence, Mysuru. So today we are going to start a new chapter, that is alcohols, phenols and ethers. So in this session we are going to study about alcohols, classification of alcohols, then nomenclature of alcohols, then structure of alcoholic functional group, and then methods of preparation of alcohols. So let us see what are alcohols. So alcohols are the derivatives of hydrocarbons in which one or more hydrogen atom or atoms are replaced by equal number of hydroxyl group. So hydroxyl group is nothing but OH group. So they have the general formula, that is ROH, where R represents alkyl groups, or it can also have a general formula, that is CnH 2n plus 1, which is again alkane's general formula, then along with that OH. So where R is an alkyl group and N can be 1, 2, 3 or anything. So classification of alcohols are based on number of OH groups present in a molecules. So alcohols are classified into monohydric alcohols, dihydric alcohols, trihydric alcohols, and then polyhydric alcohols. So its name says whether it consists of a one alcoholic group or two or three or more than three. So let us see with an example what are the classification of alcohols. So first is monohydric alcohols. Alcohols containing one OH group are called monohydric alcohols. Say for example, methyl alcohol. So one methyl and then one OH group. And in the second one, even though alkyl groups increases, but then only one OH group is present. So such type of compounds belong to monohydric alcohol. Coming to dihydric alcohol, it should contain two alcoholic groups or hydroxyl groups. So here is an example like ethylene glycol. It consists of two alcohol group. So that is why it belongs to dihydric alcohol. Next is trihydric. So this consists of three OH group, that is a molecule glycerol. And in polyhydric alcohol, it consists of more than three alcoholic group or hydroxyl group. So here is an example, that is sorbitol, wherein 1 and 4 OH group, then the other one OH, making it 6 OH groups in a molecule, that is sorbitol. So it belongs to a group polyhydric alcohols. So next is classification of monohydric alcohols. So monohydric alcohols may be further classified based on the hybridization of the carbon atom to which hydroxyl group is attached to. So in this class of alcohols, the OH group is attached to sp3 hybridized carbon atom of an alkyl group. So they are further classified as primary, secondary and tertiary alcohols. So next let us see the classification of monohydric alcohols. In that, first one is primary alcohol, wherein alcohols in which hydroxyl group is attached to the primary carbon atom, and that primary carbon atom of an alkyl halide should have hydroxyl group attached to it is called primary carbon atom, and the alcoholic group attached to it is called as primary alcohol group. Now the example is given with the general formula RCH2OH. And then example is ethyl alcohol. So this OH group is attached to the first carbon atom and this is second one carbon atom. So therefore it belongs to primary alcohol. So the second one is secondary alcohols. So alcohols in which hydroxyl group is attached to the secondary carbon atom is called secondary alcohols. So here we have a general formula R1CR2. So R1 and R2 can be any alkyl group, and this carbon has a position 2. So therefore a hydroxyl group is attached to the second carbon atom in a long chain, and therefore this type of compounds belongs to secondary alcohol. If we consider the example isopropyl alcohol, so if we go with the long chain, So OH group is attached to second carbon atom. Therefore, it is isopropyl alcohol or secondary alcohol. The next one is tertiary alcohols. So alcohols in which hydroxyl group is attached to the carbon atom containing 3 alkyl organic groups. So it is called as tertiary alcohol. So the general formula includes R1, R2, R3 are 3 different alkyl groups bonded to carbon atom, and one of the bond is with the hydroxyl group. So this type of compound belongs to tertiary alcohols, and the example can be given as tert butyl alcohol. So here all alkyl groups are attached to a carbon atom, and one of the bond is with the hydroxyl group. So next is classification of alcohols based on hybridization. So compounds containing OH group on sp3 hybridized carbon atom. So how will be the alcohols classified? So in that first one is allylic alcohols. So these are the alcohols in which OH group is attached to sp3 hybridized carbon atom, which is next to the carbon-carbon double bond, are called allylic alcohols. So here we have an example, prop 2-ene 1-ol. So if we start to number, it is 1, 2, 3. So there are 3 carbon atoms in a long chain, and double bond is between carbon 1 and carbon 2, and the adjacent atom to the carbon-carbon double bond is C3. So OH group is attached to C3 here, and which is adjacent to the carbon-carbon double bond, and therefore it belongs to allylic alcohol. So similarly with 3-butene 2-ol, so here also the double bond is between carbon 1 and carbon 2, and therefore OH group is attached to carbon 3. And therefore this is called as allylic alcohols. And similarly it goes with 2-methyl 3-butene 2-ol, because OH group is attached to the carbon atom, which is adjacent to carbon-carbon double bond. So next is benzylic alcohols. Alcohols in which OH group is attached to a sp3 hybridized carbon atom next to an aromatic ring are called benzylic alcohol. So here we have an example like benzyl alcohol. So this carbon atom is attached to a benzene ring, and then this is also bonded to OH group. So therefore it is belonging to benzylic alcohol. Similarly with 1-phenyl ethanol, so carbon bond is with the benzene ring, and also the same carbon is bonded with the hydroxyl group. So it belongs to benzylic alcohol. Here also with 2-phenyl 2-propanol, the same carbon atom which is bonded to benzene ring will also have a bond with the OH group. Therefore it is called as benzylic alcohols. So next type is compounds containing OH group on sp2 hybridized carbon atom. So here there are further classification like vinylic alcohols. So alcohols in which the OH group is attached to a sp2 hybridized carbon of the carbon-carbon double bond. So here it is directly to the carbon-carbon double bond. Here we have an example like vinyl alcohol, wherein carbon-carbon double bond is there and the hydroxyl group is attached to the carbon, which is already having a carbon-carbon double bond. So therefore it is going to belong to vinylic alcohol. Next is aryl alcohols. So in this, the OH group is bonded to sp2 hybridized carbon of an aromatic ring. So aromatic ring is there, and this hydroxyl group is going to get attached to this sp2 hybridized carbon atom of the benzene ring or the aromatic ring. Therefore the compound is phenol, and it is going to belong to aryl alcohols. So next is common and IUPAC names of some alcohols listed here. So first basic compound that we can study is about methyl alcohol. So the compound structure is CH3OH, which is having a common name methyl alcohol, and the IUPAC name is methanol. So OL represents hydroxyl group. So next is iron alcoholic group, that is consisting of 3 carbon atoms. So we should start numbering from this end. So 1, 2, 3. So this consists of 3 carbon atoms with one OH group that is being attached to first carbon atom. So the numbering has to start from the carbon atom wherein functional group is attached to it. So therefore the common name is N-propyl alcohol, and IUPAC name is propane 1-ol. So the similar structure can be written in this way also, that is 1, 2, 3, and here hydroxyl group is attached to the second carbon atom, and therefore the IUPAC name is propane 2-ol. but the common name is called isopropyl alcohol because it is branched. So next compound is little higher alcoholic group. So we have to start numbering from this end, which is having a functional group. So it is 1, 2, 3, 4. So it consists of 4 carbon groups with 1 hydroxyl group, and the common name is N-butyl alcohol, but the IUPAC name is butane 1-ol. So the same structure can be written in this way also, the second form of writing the structural formula. That is, it consists of 1, 2, 3, 4 carbon atoms in a long chain, and this hydroxyl group is attached to the second carbon atom. So therefore, the IUPAC name is butane 2-ol, and the common name is secondary butyl alcohol. So next structure is of having the same molecular formula but different structural arrangement. So we can start numbering from here. So that is 1, 2, 3. So the largest number is 3, and then the common name for this group is isobutyl alcohol, and IUPAC name can be given 2-methyl propane 1-ol. So next is of different structural arrangement but consists of a same molecular formula. So the numbering goes like this, that is 1, 2, 3. Either you can do vertically or horizontally. So OH group is attached to second carbon atom, and therefore the common name is tert butyl alcohol, and the IUPAC name is 2-methyl propane 2-ol. So next one consists of 3 carbon atoms in the long chain, but OH group is attached to all 3 carbon atoms. So it is having a common name glycerol, but IUPAC name says it is propane 1, 2, 3 triol. And the next is hexagonal ring with OH group. It's not a benzene ring, it is hexagonal ring. So it is having a IUPAC name cyclohexanol. It doesn't have common name. So next structure is of pentagonal ring consisting of 1 methyl group and 1 hydroxyl group, and the name is 2-methyl cyclopentanol. And the next structure is about CH3, CH2, CH, 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 CH to OH, wherein Cl group is attached to this carbon, CH3 is attached to this carbon, and again the second CH3 is attached to this carbon, having a name 4-chloro 2,3 dimethyl pentane 1-ol. So next is about structure of alcoholic functional group. So in alcohols, the oxygen of the OH group is attached to sp3 hybridized carbon by a sigma bond formed by the overlap of sp3 hybrid orbitals of carbon with a sp3 hybrid orbital of oxygen atom. So the COH bond angle in alcohol is slightly less than the tetrahedral angle, that is 109 degree 28. It is due to the repulsion between the unshared electron pairs of oxygen, or that can also be called as lone pair bond pair interaction. So here is an example of methanol, wherein the bonding between the carbon and oxygen is around 142 picometer, the bond length, and oxygen and hydrogen is of 142 picometer, and oxygen consists of 2 lone pair of electrons. So there is a repulsion between lone pair and the bond pair here. So the structure of methanol goes like this. So the bond angle between the oxygen and the hydrogen is 108.5 degree. Next is methods of preparation of alcohols. So first thing is through using alkenes. So by acid catalyzed hydration, how are we able to prepare alcohols? Alkenes undergo hydration, that is addition of water to carbon-carbon double bond in the presence of dilute H2SO4 to produce alcohols. So addition of an acid catalyst is needed to allow the reaction to proceed at a measurable rate. So here is a general equation: alkenes plus H2O, and in the presence of dilute sulfuric acid, that proton is from dilute sulfuric acid, gives alcohol. So in the case of unsymmetrical alkenes, addition of water to the double bond is in accordance with Markovnikov's rule. So the reaction can be seen here, that is propene reacting with water in the presence of dilute sulfuric acid and the proton which is given by sulfuric acid. So it produces 2 propanol and 1 propanol. So those 2 are alcohol groups, that is accordance with Markovnikov's rule. Next is hydroboration oxidation reaction. So alkenes react with diborane to give trialkyl borane, which on oxidation using hydrogen peroxide in alkali gives alcohol. So this reaction is called as hydroboration oxidation reaction. So for example, propane 1-ol. So it is produced by the hydroboration oxidation reaction of propene using propene. So in this reaction, propene reacts with diborane having a formula BH3 twice. So in tetrahydrofuran to form trialkyl borane as an addition product. This addition product is oxidized to alcohol by hydrogen peroxide in the presence of aqueous sodium hydroxide, and in this reaction, excellent yield of alcohol is obtained. So here is a reaction wherein propane is going to react with diborane in THF, tetrahydrofuran. So it is going to produce alkyl borane. So which on oxidation with hydrogen peroxide, it is going to give alcohol, that is propane 1-ol along with boric acid. So next thing is from carbonyl compounds. So it is by hydrogenation of aldehydes and ketones. So when aldehydes are reduced using hydrogen in the presence of nickel or palladium or platinum catalyst, primary alcohols are formed. So here is an example, that is aldehyde in the presence of hydrogen, that is in the presence of catalyst, maybe palladium, platinum or nickel. It is going to produce alcohol. So let us see with an example, that is propane aldehyde in the presence of palladium catalyst. So it is going to produce propyl alcohol. So next is when ketones are reduced by using hydrogen in the presence of nickel catalyst, secondary alcohols are formed. So here is a ketone group. In the presence of hydrogen, in the presence of nickel catalyst, it is going to produce secondary alcohol. So this second alcohol wherein hydroxyl group is attached to it. So therefore it is secondary alcohol. Example, acetone with hydrogen wherein in the presence of nickel catalyst. So it is going to break this double bond between carbon and oxygen to form alcoholic group. So it is isopropyl alcohol. The next example is pentane 3-one wherein it is going to give pentane 3-ol. So hydroxyl group is going to attach to this second carbon atom, secondary alcohol. Therefore it is pentane 3-ol. So next is by reduction of carboxylic acids. When carboxylic acids are reduced by a strong reducing agents like LiAlH4 followed by hydrolysis, primary alcohols are formed. So here is a general equation, that is carboxylic acid in the presence of LiAlH4 and THF. It is going to give primary alcohol. This hydroxyl group is going to attach to the first carbon atom. And then example can be seen here, that is acetic acid. So acetic acid in the presence of the given condition. So it is going to produce primary alcohol, that is ethanol. And the second example is propanoic acid. So it is going to consist of 3 carbon atoms, and under the same condition it is going to give propane 1-ol. So next is from Grignard reagent having a general formula RMgX. So when Grignard reagent is treated with aldehydes or ketones, addition products like magnesium salt are formed. So these products on hydrolysis gives alcohols. Example, formaldehyde gives primary alcohols and other aldehydes give secondary alcohols, and ketones can yield tertiary alcohols. So aldehyde in the presence of Grignard reagent mixture, that is in dry ether medium, it is going to form a magnesium salt, and then on hydrolysis it is going to give secondary alcohol. And for the ketone group in the presence of Grignard reagent, that is in dry ether medium, again it is going to form a magnesium salt, but on hydrolysis it is going to produce tertiary alcohol. So let us see with an example, that is formaldehyde along with the Grignard reagent. Grignard reagent we have taken methyl magnesium bromide in the dry ether medium. So it is going to give a salt of magnesium, and therefore on hydrolysis it is going to produce ethanol and the byproduct MgOH-Br. So that was about today's session. So in the next session we are going to study about physical and chemical properties of alcohols. So thank you.